Hello everyone, my name is Utkarshi Chauhan and in the previous video we had discussed about the exploratory data analysis, and in this video we will discuss about the data preparation phase to model the data. So, so first we understand with the help of PPT and then with the help of code. So let's begin with the first topic, how to partition the data in Python. So first we understand what is data partitioning. Splitting data into training, validation, and testing sets. Importance is prevents overfitting and ensure the model generalize well. And key parameters in partitioning is training set, testing set, and the test size and random set and stratified. Now move to the another one, how to balance the training data set in Python. So first, what is imbalanced data? When one class has significantly more samples than others. So what's the problem in that? Models become based towards the majority class technique for balancing, and oversampling adds synthetic sampling to minority class. For example, SMOTE. Undersampling removes samples from the majority class. And now move to the another one. So move to another one, how to build random forest in Python. So first we understand what is a random forest. An ensemble of decision trees combines the prediction of multiple trees to improve accuracy. So why use in random forest? For reducing overfitting compared to a single tree and work well with a large data set and a high dimensional data. Move to now understand with the help of code. So first, how to partition the data. First, we import the libraries, and from sklearn.model selection import train test split, and then from sklearn dataset import load iris, and then we load the iris dataset, and then xy is equals to iris data iris dot target x for features and y for labels, and then we partition the data into a training and test sets, and the test size is equals to 0.2 of the data will be used for testing, and stratify is equals to y ensure the classification distributing in similar in both sets, and then output the shape of the data set. For printing the outputs, just print and f training set shape features xtrain dot shape, and print testing set shape features test shape. Now we will see the output of this code. So the training set shape feature 120 and 4, and testing set shape feature 30 comma 40. So the explanation of this code is the training set 122 rows for example and 4 columns features, and 80% of 150 samples is equals to 120 samples for training, and testing set 30 rows examples and 4 columns features, and 20% of 150 samples is equals to 30 samples for testing, and for feature sepal length, sepal width, petal width, and petal width. The output tells us how dataset was divided for training and testing, ensuring an equal class representing in both sets due to stratify is equals to y. 5. Now move to the another one. How to balance the training dataset Python. So first we import the first we install the pip install and install imbalance library only for the collab, and then import the necessary libraries like from imblearn.oversampling import SMOTE, and from sklearn.dataset import make classification, and from collection import counter. Then we generate a synthetic imbalance dataset, and weight is a 0.0 comma 0.9, and means the 10% sample belongs to one class and 90% to another one. And then we check the class distribution before balancing with the printing. Print f class distribution before balancing counter y. And then we apply the SMOT, stands for a synthetic minority over sampling technique. We apply this and then we check the class distribution after balancing. Now we see the output of this code. It's running. So class distribution before balancing counter uh, 1 18950 and the data has two classes, class 1 majority class 895 samples and class 0 minority class 105 samples, and this shows a significant class imbalance where one class 1 dominates the data set, and after balancing counter 1 1 colon 895 comma 0 colon 895. Now both classes have an equal number of samples, class 1 895 samples and class 0 895 samples. And then we move to the another one. So the third is how to build card decision tree using Python. So first we import the necessary libraries. These are the necessary libraries for build card decision trees using Python. And then we load the iris dataset and split into training testing sets. Like that, iris is equals to load iris and xtrain, xtext, ytrain, ytest is equals to train test split iris data iris dot target, and test size is a 0.2 and random state 42, and then build a card decision uses a Gini impurity by default. In that criterion Gini max depth is a 3 and random state is a 42, and then we train the decision tree on the training set. And for the visualization the decision tree, we use the plt.figure fig size 12,8, and for showing the decision tree plt.show. Now let's see what's the output of this code. Now this image depicts a card decision tree classification and regression tree, and used for classification data. Now, this image depicts a card decision tree, classification and a regression tree used for classifying and data into different categories, likely from the iris data set. And the tree is constructed based on a condition applied to a feature like petal length and petal width. Here is a detailed breakdown of the tree, and this is the root node, and this is the root node top level, and condition is a petal length centimeter is less than equal to 2.4445, and the Gini index is 0.6600, and the Gini index is 0.667. Measure of the impurity lower value means purer splits, and then samples 120 total data points at this level, and then values 40, 41, 39 distribution of classes Sesosta, versicolor and Virginica, and the class versicolor majority class at this level, and so on. And now we move to the another topic, fourth one. So fourth one is a how to build C5 dot decision tree using Python. So first we import the necessary. So first we import the necessary libraries. These are all are the necessary files, and then we load the iris dataset and split into training and testing sets. And iris is equals to load iris, xtrain, xtext, xy, and so on. Then we build a decision tree using entropy similar to the C5 dot 0, and then we measure the entropy in so information gain for splits, and we visualize the decision tree. And for visualization, mm, we use the plt dot show. Now this is the output of the above code, and. This is the output of above code. C50 decision tree using entropy petal length centimeter is less than is equals to 2.45 and entropy is the 1.585 and sample is 120 and the value is 40, 41 and 39 and the color and the class is versicolor, true or false and so on. Now move to the another one. How to build random forest in Python. So first we import the necessary libraries. These all are the necessary libraries and then we load the iris dataset and split into training and testing set like that. And then we build a random forest with 1000. Sorry. Then we second build a random forest with 100 decision tree. RF is equals to random forest classifier and estimator is equals to 100 and max depth is a 5 and random state is a 42. And then we train the model with rf.fit extend comma ytrain predict on the testing set with this y predict and is equals to rf.predict xtext. Then we print the evaluation matrix with the help of print classification report ytest and y predict. Now we will see the output of this code. So the class 0, precision 1010, all predicted sample of class 0 are correct and recall 100, all actual sample of class 0 are correctly predicted and F1 square 100 perfect performance for this class and support 10. There are 10 instances of classes 0 in the dataset and class 1 precision recall and F1 1.00 perfect performance and support is a 9. There are 9 instances of class in the class 1 in the dataset and in the class 2 precision recall F1 square 1.1 perfect performance and the support is equals to 11. There are 11 instances of classes 2 in the dataset overall matrices. So the accuracy of that is 1.00. The model correctly classified all 30 instances in the test dataset and macro average is a precision recall f1 square is equals to 1.00. All classes are perfectly classified and equal importance is given to all classes since the score are average equally and weighted average is a precision recall f1 square is equals to 1.00 since all the classes are perfectly predicted the weighted average consider the support is also perfect. So now these all are the topics we have discussed in this video. I hope you are understanding. Thank you for watching my video.